In section 8.4, we're going to look at quadrilaterals and their diagonals. But before we do that, we need to look at some examples and figure out what can be said based on the information that we're given. So if we look at this first example, we have two line segments that are going to represent the diagonals of a quadrilateral. And there is some information that we are given. We are given that this segment from B to here is congruent to the segment from D to here. So we are given that BD is being bisected. So the statement that I can make about this first diagram is that LM, segment LM, bisects segment BD. Because one of my diagonals is being bisected, that's the conclusion that I can come to based on these diagonals. One diagonal is bisected. Now if I look at example 2, again, I have enough information given to me that BD is being bisected. So I know that segment LM bisects segment BD. But I also know that LM is being bisected. If we look, this segment from L to this point here is the same as from M to this point here. So I also know that LM is being bisected. So BD is bisecting LM, which means that these two line segments bisect each other. So the conclusion that I can make based on this diagram is that my diagonals bisect each other. Now if I look at my third example, if I look at the information that I'm given, again, I'm given that B to this point is the same as D to this point. So I know that LM bisects segment BD. I'm also given that L to this point is congruent to M to this point. So I can also say that LM is being bisected by BD. Because both line segments are being bisected, I can conclude that my diagonals bisect each other. But there is something different about this picture. If I look at my line segments, from B to this point is the same as from D to this point. It's also the same as L to this point and M to this point. So I actually have 1, 2, 3, 4 congruent segments. And if I look at my entire diagonals, the entire length of BD is going to be congruent to the entire length of LM. That's different than example 2, where my entire length BD is not congruent to my entire length LM because they're made up of different parts. I have congruent parts within each diagonal, but the entire diagonals are not congruent. In my third example, the parts that make up each diagonal are congruent to each other, so I can say that LM is congruent to BD. Because my entire length LM is congruent to BD, the conclusion I can say based on that is that my entire diagonals are congruent. When I make that statement that my entire diagonals are congruent, I'm talking about my entire length from L to M and from B to D. Not just parts, but the entire thing.